Hello students, my name is Sumit Mehta. So in today's lecture we will discuss about what is differentiability. Okay, so till far we have discussed about what is limit and how to check whether the continuous continuity of the function. Okay, so now I am checking, writing here is suppose f is a real function. Okay, and C is a point in the domain of the function, in its domain. Okay, the derivative of f at C is defined by limit h tends to 0 f of C plus h minus f C upon h. So this is the formula to find out the derivative of function f at any defined value, and we can also write it down as f dash x is equals limit h tends to 0 f of x plus h minus fx upon h. Okay, so this is f dash x is also can be written as d by dx of f of x. Okay, so student, this is the formula to find out the derivative of the any function at x. Okay, now some rules, or you can say the algebra of the derivatives. Okay, so first is u plus minus v dash means u and v are functions, or you can say, let's say u is fx and v is gx. Okay, so u, either it is plus or minus v, the derivative of the combined function is u derivative plus minus v derivative. Okay, the second rule is uv dash, the derivative of the product of two functions is derivative of the first function plus second as it is plus first as it is derivative of the second function. The third one is u by v formula dash, so it is u dash v minus uv dash upon v square. Okay, so these are some important formulas in algebra of derivatives. And students, I will tell you that how to find the derivative of the functions simply without using this formula also. Okay, so there are some derivatives that you need to remember, and that these derivatives will help you solve a lot many problems. Okay, so students, let's say if the function is given to you as x to power n, so the derivative of this function is to find the derivative of any function in variable to the power constant. N is constant where the constant becomes uh, downwards, okay, and the power is decreased by 1. Okay, so the derivative of this function is power comes forward and the 1 is subtracted from the power, and the function is like, if it is sin x, so the derivative of sin x, or you can say it is cos x, and so these are the examples, student. These you need to remember by your heart. Okay, so the f dash x is minus sin x. If fx is cos x, the derivative of cos x is minus sin x. So the third is tan x. So the derivative of tan x is secant square x. Okay. So these are the some important derivatives. Now let us discuss about the derivative of the composite functions. So now we will discuss about some derivatives of composite functions. So let's say the function is given to us as 2x plus 1 whole cube. Okay, so to find the derivative of this function, d by dx of fx is equals to d by dx of 2x plus 1 whole cube. Okay, so as I have told you, the power comes earlier and the system get reduced to 1, or what we can say is we can open the cube. Okay, so if I apply the formula of a plus b cube, the function is becomes like this. Okay, so for that I can write, if now I will apply the d by dx, so 8 into 3, the power comes earlier and the power is reduced by 1, the power becomes forward comes forward, so 12 into 2 24, power is uh, decreased by 1, and this is power is 1, so power comes forward, which is 6 into 1 6, and 1 is less, degree power is decreased by 1, so x to power 0 is 1 here. So the derivative of this function is this, so you can say that 24x square plus 24x plus 6 is the derivative of these functions. Okay, so I hope students now you are pretty clear about the composite functions, how to solve the derivative of composite functions. Okay, and there is one more rule which is called as chain rule, which states that let f be a real, let me change the color, real valued function which is a composite function. Okay, composite of two functions. Let's say f is v of u. Okay, so to find the derivative of f, what I will say, if I find df by dt, so let's say dv of u by dt into, if I need to check df by dx, so what I will do is this. First I will differentiate it with respect to t. Let's say if a function b is given in t and this is also given in t, so and I need to check the derivative of function with respect to x, so I'll apply the chain rule here. Okay, so this is the chain rule, students. This will become more clear to you when you will see the questions based on it, and in the next lecture we will discuss some questions based on differentiability and how to differentiate these some functions. Okay, so stay tuned for that lecture on questions based on differentiability. Thank you, students. Happy learning. Stay blessed.